All right, these are the difference quotient notes. So in calculus, you will use the difference quotient in order to find the derivative, and it's lovely. But what we're going to do here is just get used to the algebra kind of behind the difference quotient. So we're going to be plugging in to this formula. What we know every time, what we're given every time is f of x. And I will absolutely give you the difference quotient formula on the test. That's not something that you have to have memorized at this point. So our goal is to get rid of the h in the denominator. Our goal is to be able to algebra until we can cancel that. That's our goal every time. If we can do that, then usually what we're doing is taking the limit as x approaches h, or as h approaches 0. So if we're doing the limit as h approaches 0, having that h in the denominator is a problem. So we're going to get rid of it. We know f of x. F of x is, in this first example, 2x plus 5. So what we're going to do is we're going to put this into that formula up there, f of x plus h minus f of x all over h. Here's how this works. F of x plus h, so that we're going to put in for x. So that piece right there, f of x plus h turns into this, 2 times x plus h plus 5. And then we subtract f of x. And since that's usually going to be 2 or more terms, we're going to put that in parentheses. That's probably the most important part. And then we're all over h. So f of x plus h, we're just putting that x plus h in for x, minus f of x, minus the whole entire thing, all over h. And now we're going to algebra from there. Again, our goal is to get rid of the h in the denominator. I'm going to start by distributing the 2 and distributing the negative. 2x plus 2h plus 5 minus 2x minus 5 all over h. Lovely. So this is not difficult. You just have to be very precise. If we look at what we can cancel at this point, I have a positive 2x and a negative 2x. I have a positive 5 and a negative 5. So what I'm left with is 2h over h. My h's cancel, and I'm left with 2. Beautiful. So I think the two things that are tricky about this are, one, the initial plugging in, remembering all the pieces, and then just being precise with your algebra. All right, we're going to do the next example. I'm going to use the same colors here, actually. So my f of x here is 3 minus x. So when I do my f of x plus h, instead of x, I'm going to have x plus h. So I'm going to do 3 minus x plus h. And then in my equation, I have a minus in the middle there. My f of x is 3 minus x. And it's all over h. So that's a lot of parentheses there for something that looks really simple to start with, but they're all important. Here we're f of x plus h is, we have to have that x plus h there in the equation, minus f of x. Okay, now we math. 3 minus x minus h minus 3 plus x all over h. And you know things are going well if you can cancel a lot. So I have a positive 3 and a negative 3. I have a negative x and a positive x. So I'm left with negative h over h, which is just negative. So careful, precise algebra is the way to go here. So we have to be careful when we're dealing with x squared. Again, our equation is this, f of x plus h minus f of x all over h. So when we're squaring, hopefully you're kind of forecasting what I'm about to say. We're going to have to be really careful with squaring the binomial. So here, f of x plus h is going to look like this. X plus h, that whole thing squared. Minus f of x, which is just x squared, all over h. Again, it's the precision here that you have to be careful with. You can't just square the x and square the h. Your next step should look like that. Or if you kind of do this as scrap work, that's fine as well. But just make sure you're squaring that binomial the right way. So x times x is x squared. I'm going to have 2xh's. I'm going to have h squared. And then I'm going to subtract that x squared. That was our minus f of x. And now let's see what we can cancel. With the last one, if I could cancel a ton, here I can just cancel those x squareds. I have one positive and one negative. So what I'm left with is 2xh plus h squared all over h. Be careful here and don't just cross out. I would factor before I cancel. Both of these terms have an h in common. When I factor out the h from 2xh, I'm left with 2x. When I factor out the h from h squared, I'm just left with an h. Now I can legally cancel. Your other way to do that would be to break it up over the common denominator. If you're more comfortable with that, that's the way it would look. Either way, you're going to be left with 2x plus h. So if our h is approaching 0, that's fine, right? That's the work that we're working toward for when you get to calculus. Here, if our h is approaching 0, and you have 2x plus h, you don't have any zeros in the denominator. You're in good shape. All right, I think I'm going to do one more problem on this video. I have 2x squared minus x. So the more terms you have, kind of the more complicated your x plus h situation is going to be. When I'm doing f of x plus h, I'm going to put x plus h in here both places for both x's. So it's going to look like this. That's my f of x plus h. Now my minus my f of x, it's going to look like that. And then all over h. All right. Now, again, you want to be really careful with your precision here. You have a lot of distributing to do. The nice thing is that it is kind of repetitive. You know, here, you're going to end up with x squared plus 2xh plus h squared. But you still have that 2 on the outside that you need to multiply through. So don't forget about that 2, and you need to apply it to everything there. But you also need to multiply through the negative on the negative x plus h minus x minus h, and on your 2x squared and your negative x, that's going to become positive. So this one is going to take an extra step here of distributing. And end up with 2x squared plus 4xh plus 2h squared minus h minus x minus h minus 2x squared plus x. And now what we want to be able to do is get rid of all of the x terms, hopefully, so that we can cancel our h. If we have an x term left on top, something broke, like we didn't do something right, because then we can't cancel that h. So I have positive 2x squared and negative 2x squared. have a negative x and a positive x. And what I'm left with is positive 4xh, positive 2h squared, and negative h over h. So since I have h's everywhere, I'm going to be in good shape. 4xh plus 2h squared minus h all over h. If you want to factor out before you cancel, I always think that's a good idea. Here, I'm going to be just left with 4x. Here, I'm going to be left with 2h. And here, the one to not forget, I'm going to be left with minus 1. So, it seems like a super crazy answer, but it's the algebra that we're working toward here. You will do the calculus next year. All right, the next video will have some more examples for you.